Hi, everyone, and welcome to this live lesson. It's absolutely wonderful to have you all with us. Today's live lesson is Women on the Frontiers of Climate Science, looking at our changing planet, and more importantly, celebrating the International Day of Women and Girls in Science. Very shortly, we will meet our fabulous and awesome scientists, Ceri and Georgie. But before we do that, a little bit of housekeeping and some shout outs. Many of you have joined Encounter EDU live lessons. This live lesson is part of a new series, Ocean and Climate Live, part of the Convex Seascape Survey. So, asking questions. There's a chat app beside the screen, and that's where you put all your questions. That's where the polls during this lesson will come up. If you would like to have the video full screen at the front of the classroom, then please do that. But teachers or parents, you may want to open up the lesson on another device so that you can interact with that at the right times. We'll do most of the questions, pretty well all of the questions at the end of the live lesson. We've got a Q&A session for that. If someone has asked a question very similar to the one you would like asking or answered, just click on the thumbs up button beside that. That upvotes that question, and we'll take the most popular questions first. Any technical issues, there's a chat button in the bottom right-hand corner of each page of the Encounter EDU website. And so just click on that and you'll be put in touch with the support team who hopefully will sort whatever issues you have out and carry on with the wonderful live lesson. Before we meet Georgie and Ceri, I just want to go over the learning for this lesson. So we have 4 things we want to learn about. We want to learn about what a professional scientist actually does. What does a scientist do? And look at those working scientifically skills. We want to think about a STEM career and how you can progress through that. We also want to make sure to learn about equality, not only in careers, but in aspirations. So we're going to meet some professional scientists who are in their career, but I want everyone there, whoever they are, to be able to aspire to their dreams and what that job might entail. And last, but by no means least, is to really take the opportunity to celebrate all the wonderful women who work in science and who have worked in science over many, many centuries. So without further ado, it's my great delight to welcome Ceri and Georgie from the University of Exeter to this Encounter EDU live lesson. Hi, both of you.
Hi, Jamie. Hi.
Wonderful to have you both with us. The first section we're going to look at is really about you. What does a scientist actually do? And so in this section of the lesson, this is learning about some of those activities, skills, words to do with your wonderful careers. For those, I think we've got a student sheet for this. We can come to this in a bit, but very briefly, I'd love it if just in turn, start with Ceri and then Georgie, just tell us a little bit about some of the awesomeness you've been involved in looking at our changing planet. Ceri.
Thanks, Jamie. So I'm an associate professor in marine biology at the University of Exeter, and my research focuses on trying to understand how human actions affect the small animals at the bottom of the marine food web. And as part of my research, I'm very lucky. I've been to some very exciting places. Possibly one of my favourite is the Arctic. And the photo behind Jamie is of me in the Arctic, where we went to study the impacts of plastic pollution on the tiny zooplankton, which are tiny little animals that live in the Arctic Ocean.
And you have one round
Yes,
your...
I do. I do have my little copepod necklace on today.
Fantastic. They're a bit smaller than that, about the size of your pinky fingernail. That's amazing, and we'll come to a little bit about what working in the Arctic is like, because that sounds awesome. Georgie, welcome.
Hi, Jamie. Yeah, my name is Georgie, and I'm a PhD student at the University of Exeter. So that's basically a degree you do after you've been to university, and then you get to call yourself a doctor at the end of it. And then hopefully you can go on to become a lecturer and a professor like Ceri. So my research focuses in the Galapagos. So the Galapagos is in the big Pacific Ocean, and it's a set of islands there with this incredible amount of wildlife. And we're looking to see the effects of plastic pollution and other chemicals, such as oil from ships and boats and pesticides from farmers, and to understand the impacts of those on the Galapagos and the wildlife there.
Amazing. Thank you both so much. I think what would be lovely to understand is that we have this sort of idea of scientist. What are some of the things that you actually do as a scientist, wherever that may be?
I'll let Georgie go first. Georgie, because is at the earlier stage in the career, so that might make more sense to hear from Georgie first.
So yeah, I think a day in the scientist as a scientist really varies. And it varies depending on what stage of your career you're at, like Ceri said. So for me, my week will vary.
A manager of lots of different scientific projects, which is exciting for all sorts of different reasons. You get to be involved in many exciting projects. But because I'm a researcher at a university, I also teach. So I spend about 40 to 50% of my time teaching undergraduates the skills to be a marine biologist of the future. So I love that side of the job as well, really infusing people to want to be marine biologists in the future.
Amazing. Thank you both very much. Classes, you have a student sheet, but we can jot these down on a blank piece of paper as well. So we've got this idea of where you work in the Arctic, in the Galapagos, and also in the lab down in Exeter. What else? I just wanted to touch on some of those sort of like things that you've both done. There seems to be quite a lot of traveling involved. Tell us a little bit about that.
So traveling is one of the perks of the job. I love being able to go and work in lots of different parts of the world, and I choose the locations for our fieldwork according to the questions that I want to ask about them. So the Arctic is really important as a sink of plastic, as is the Galapagos. These are both locations of the world where plastics interact with lots of wildlife, because there's lots of nutrients in the water in both of these regions, so lots of life. And also plastics from human action. So we pick our travel locations not just to be exciting, but to ask the questions we're interested in. But they're normally exciting too.
And then I sort of, you touched on sort of sampling, Georgie. What's all that about? I mean, you're not just going to these places, as Ceri mentioned, for a holiday.
No, we'd love it to be a holiday. There's some incredible places like Ceri mentioned, but we do have to do quite a lot of work when we're there, and it's actually quite tough work. We're generally in very remote conditions, so it's kind of like being on an adventure, being an explorer. We use different scientific techniques to try and sample for plastics in those areas. So we might be doing something called a transit, which is where you lay out a tape measure and then you collect the plastic at different intervals along that tape measure. Or Or we might be using big nets, and we might then be towing them behind a boat and sampling for the smaller plastics in the sea. Or we might be using these hand pumps, and we might be in amongst the trees in the mangroves and pumping the water like that to try and get samples. So there's lots of different ways we collect samples.
Amazing. And we come to then to sort of processing. You can't just, I mean, can I just pick plastic up on a beach and say we found this much, or is it more complicated than that?
So it kind of depends on the type of plastic you're looking at. If we're looking at these larger bits of plastics, a lot of the processing is counting and categorizing. So we might look at the color of the plastic, or where we think it's come from. Do we think it's a bit of fishing net? Do we think it's come from a water bottle? So that's the kind of processing we do for the larger bits. But when we're trying to look at those really tiny, small bits of plastics, it can be a bit more difficult because often we can't even see those plastics with our own eye. So then we've got to kind of separate the plastics from whatever other material is in our sample. So that might be sand, or it might be those little copepods that Ceri was talking about. And then we've got to use a microscope to try and see those plastics, because microscopes really help us. They zoom in so we can see the plastics a lot easier. And then we need to categorize what plastics they are, because they're all from different sources and different materials. And we use a very fancy bit of kit to do that, called an FTIR. And it basically zaps the plastic with a really special red light. And then that red light can tell us the type of plastic that it is. Amazing.
And then can you just conclude and write what's happening on the planet based on just looking at stuff under a microscope and counting things? Or is there another stage before you can share what results you have?
Yeah, so usually we have to then analyze that data. So actually, we as human beings, we give off a lot of plastics from the clothes we're wearing or the activities we're doing. So we've got to be really careful that those small plastics we're finding are not actually from us. We're actually in the environment when we got there already. So we have to do some calculations and subtract plastics from our total amount so that we can really know the plastics that were actually in the environment, and then we can start writing and start communicating those numbers.
Amazing. So what I'm hearing is there's travel, there's science, there's maths, and then finally there's a lot of literacy involved in being a scientist.
I think communicating the science at the end is probably one of the most important parts of our job, because if we do all this fantastic science and nobody knows about it, there's almost no point. Nobody knows the importance of our findings. So it's really important that we do our science very carefully, but then we communicate it to as many people as we can as well. We do that by writing scientific papers and by talking to people like you, Jamie, but we also go and talk to policymakers because we're working on a topic where actually regulations can be put in place to help control plastics in the environment. So we spend a lot of time going and talking to government ministers and people like that as well. And right at the moment, there is a big discussion happening all around the world about the Global Plastics Treaty. And so we're also making sure our data gets put into those discussions as well.
Wow, an amazing job by awesome people. We'll come back with some of the questions to some of the best bits of the exciting work you're doing. But I just want to shift this lesson to looking at the importance of women in science more generally. And there's so many wonderful sewcientists who have been doing work over many centuries. But one of the things that struck me when we were preparing for this lesson, if I look at the Nobel Prize for scientists and for the sciences, and it's sort of probably the biggest prize in science, the numbers, I think it's sort of 580 something men have won it versus about 20 women. And it just seems bonkers to me. I'd love it if you can share some of the scientists who we female scientists, women scientists who we should know more about and who should be celebrated more widely. Do you each have a science role model that you could share with the classes watching?
Yeah, shall I go first and tell you about one of my heroes, a wonderful marine biologist called Rachel Carson. Now, Rachel Carson was born more than 100 years ago. She was working in a time where women were not welcome at sea at all. Hardly anyone was diving. Man hadn't even landed on the moon yet. So we didn't have any of these big technological tools for looking at the ocean. But she wrote a wonderful book. It's called The Sea Around Us. And so she was writing at this book when we couldn't really use satellites or submarines to understand the sea. And yet some of the wonderful way in which she talked about the oceans really was really insightful and opened up the oceans to a lot of people. So she helped connect people with the oceans when other techniques didn't really exist to do that. But what Rachel Carson is probably most famous for is writing a book after that called Silent Spring. And that's where she highlighted the impact of pesticide chemicals. This one was called DDT. It's quite a famous pesticide for controlling lice and for mosquitoes. It was used for malaria. And it's also incredibly toxic. But people thought it was wonderful at first and were using so much of it that it started having really big impacts on wildlife. And we didn't really have regulations for environmental use of chemicals until she wrote that book. It was a real moment in history where people started to think differently about the interactions of humans and their impacts on wildlife. And a whole field of environmental chemical regulation, which is what Georgie and I really work in now, started because of that book. And she was really given a lot of people really nasty to her for writing that, for challenging the status quo, but she really changed whole field of science. So she's a big hero of mine.
Thank you. Georgie?
Yeah, so one of my my role models, I guess, is Sylvia Earle. Now, Sylvia Earle is a marine biologist from America. She is now 87, actually, and she's still doing marine biology. And she was one of the first women to use modern diving equipment known as scuba, which are those big tanks on your back and those breathing apparatus. She was one of the first people to use those to dive. She was also really heavily involved in developing underwater submersibles, which are these little pods that scientists use to go all the way down to the seafloor so that they can look at all the marine life on the seafloor. So she was hugely influential in both of those bits of scientific equipment, which we now really value to sample our oceans. She's also a National Geographic Explorer, which is a very cool title, and she gets to go to some incredible places around the world, including the Galapagos, actually. And she's just a really great woman. And she now as well is doing a lot of science communication. She's writing books and doing documentaries to really get young people involved in ocean science and to raise the awareness around some of the threats that our oceans are facing at the moment, such as plastic.
I think thank you both very, very much. If I can have one of my science role models, would be the world's first computer programmer, Ada Lovelace, in the 1840s. I think over 100 years before someone built a machine capable of running her program. And I think one of the things I love about her is that her work combined both maths and poetry. Her father was a very famous poet called Byron, and she combined those two trends, or those two ideas, and wrote the first computer program, which wasn't just maths. So I think when we think about programming as a career, the first one was a woman. I think that's awesome. We've touched on this idea of, there are so many awesome women scientists that they've been overlooked for probably, I don't know, ever since we had an idea of science or what science is. I want to look, and this is a sort of poll section of the lesson for classes watching. The poll will come up in the poll tab in the interaction app where you can type the questions. I want to think about what the barriers are to women and girls in science. And I think on the slide for this section is this, picture of a cartoon Einstein. Can I just ask you, sort of, when people say scientist and they think that, how does that make you feel?
Well, it could be a woman. And I think it depicts, a situation where scientists have to be these really crazy people. And actually, I think as long as you are curious and want to ask questions, then you are a scientist.
But I think that image of a male professor in a white coat was the image that I grew up with when I was doing my PhD, which is 20 years ago now. There were no female professors in my department that I was working in, and that's what male professors really did look like. So I understand where that stereotype comes from, but that's really not the world we live and work in now. There are so many amazing women scientists, but also scientists don't all wear white coats either. So it is quite an old-fashioned view of a scientist. But certainly people like Georgie and I are definitely trying to change.
Perfect. So I think we can get the first poll up now, and it's going to ask classes. We'll give you a minute to do this, to order these subjects 1 to 4, with number 1 being the most suited to women and girls. So the 4 sciences we have are engineering, computer science, maths, and nature sciences. Ceri and Georgie, I'll let you rank these 2, and we'll come back in 1 minute to see how you got on. Amazing. I can see some of your answers coming through. We've got maths and nature coming top, engineering sort of in the middle, computer sciences at the bottom. So we've got that flavor of women and girls more suited to mathematics, more suited to the natural sciences, but engineering and computers probably more suited to men, boys, that side. Ceri and Georgie, any comments on that?
Well, I think that was quite a mean question, Jamie, because it's a bit of a trick question, isn't it? But of course, we can do all of those things. I don't think there's any difference in any of those subjects for what women can do. I'm sure Georgie agrees.
Yeah, I would definitely agree. I think women and girls are able to do any of those different types of science, and it's also worth adding there are lots of other options there as well. I think probably we are seeing more women in natural and nature sciences at the moment, but that's not to say that it's like engineering and maths and all those other types of sciences are equally available for women as well.
Yeah, it's one of those societal things where this gets repeated over and over again, and it becomes a fact. There aren't any sciences that are more or less suited, but we might come on to whether it's harder for women if it's a male-dominated field in just a little bit. So we're going to come on to our next poll, and we've got the slide up, and that is showing you the different stages of an academic career. Where so we've got, first of all, we've got university. That's a sort of normal university degree. Then we've got studying for a doctorate, PhD. Georgie, that's the stage you're at. And then we've got people who speak on panels at conferences and that kind of thing. Professional scientists, Ceri, that's your stage. And then the sort of national level science. We have the sort of like the top sort of, whether it's a Royal Society or these national academies, these sort of very elite bodies. And we'll just give you another minute to think about what percentage of science professionals do you think are women? And then afterwards I'll let Ceri and Georgie just review and talk through more of this data. Brilliant, thank you. Great work in those classes, and I'm going to let Ceri and Georgie take you through the answers and also what that represents in terms of these global percentages of women versus men at different stages of a science career.
Georgie, if you go first.
Okay, so the answer for the PhD students is actually 44%. So that would have been your closest answer. And I think it, again, depends on the type of science you're doing. But certainly for science based around the environment and around nature, I think we do see quite an even split of male and female at PhD level. But perhaps the picture starts to change a little bit when you move up those levels and get to career levels such as the one that Ceri's at.
That's right. And so when you become a professor at a university, actually only 28% of professors are women. And that's where we really start to see the disparity. And then if we look at the bars on your poll, the speaker on panels, that's 33% are generally women, and professional scientists, that's 30%. And those numbers really do reflect my own personal experiences. Quite often I'm asked to go and join panels because they need a token woman to be involved. They desperately want to try and get women on these panels and they struggle to find them. And I'm not really sure why that is, but it's definitely an area that we need things to change. Whenever you're doing panels, generally most people are now trying to get 50-50 splits, but it's quite difficult and isn't always managed. But yes, 28% are women, and women are still paid less at the top of universities as well. So it's those top tier leadership type roles where we still see these differences.
Brilliant. Thank you both. We've got loads of questions coming through, so I just want to touch on a few things. First of all, there's one part of science that I think is really, really important for everybody to think about is AI. And we have a last poll on AI, the percentages of women in AI. I'm very sorry, classes, but we're going to whip through this because I really want to come to your questions. So I'm just going to tell you the answer out of these choices is 22% of AI professionals are women. Ceri or Georgie, why is this a problem? We talked about it being bad for women, but actually it's women scientists, but it has all of this has an impact on the rest of us.
Absolutely. And it's something that I've started to worry about a lot recently because of how AI is being used in many aspects of life, but in particular around job applications for our undergraduate students. So I have third year tutees, so students who are about to finish their undergraduate degrees and are trying to go and get jobs. And an awful lot of the early career interview stages are now done online on Zoom like this and are analysed not by a real person sat the other side of the screen talking to you, but by these artificial intelligence algorithms. And if they're all written by men and those unconscious biases get written into those programs, then women are less likely to be competitive for those jobs. So it is a real area of concern and something I think certainly governments and universities need to take a very close look at to make sure we're not taking some steps backwards and putting more gender bias into decision making. Because we've made a lot of progress, certainly in the time that I've been at universities. Things have changed so much. It's a very, very different world from when I was an undergraduate. But here's a technology that might undo some of those good steps if we're not careful.
Brilliant, thank you, Ceri. But before we go into the Q&As, I just want to sort of look at some sort of tips that you both have. Ceri, you've talked about making sure that university systems are fairer and pay is equal. Is there anything else for universities that you think need to be done to make an equal playing field for men and women, boys and girls?
Well, like I said, I think some huge steps have been made over the last 10 years to really address the disparities that happen at early career stages where you might be starting a family. So women can have kids and still have really dynamic, exciting academic careers now. But I think the challenges still remain when you start to push for being a professor, those top leadership roles. We absolutely need women at the top of universities as well. And that's where we still don't have as good a representation. And I think universities have to look at that very carefully. It's not obvious what the things are that they can put in place to change, but they certainly need to be looking for those opportunities.
And anything you'd like to see different in the primary science classroom? What would you love all our teachers to be doing?
Apart from telling everybody all about the wonderful marine environment much more, because obviously that's my passion, but I think having a sense of the huge variety of amazing, exciting jobs you can have as a scientist, so that when you're thinking about scientists, you're not thinking about that old man in a white coat. You can think of the person in a submarine at the bottom of the ocean, or you can think of somebody up a mountain studying how the glaciers are melting. You're aware of this huge variety of jobs. Just within marine biology, you don't have to be someone who likes snorkeling or scuba diving to be a marine biologist. You can sit at a computer and analyze big data sets. You can look at satellite images of the ocean. So there are so many different ways of doing science. I think the more kids at school know about, all the different exciting things you could be doing, the more likely you are to think that's something you might be able to do and not see barriers, but see opportunities.
Amazing. Thank you. So wonderful. We've got some wonderful questions, so I want to get to those as well. We've got Penthorpe School, and I know Year 5 are working really hard on their careers education at the moment, so this is a fantastic lesson to be having. Hi, everybody at Penthorpe in Year 5. They wanted to ask the most important skills or qualities that a scientist needs.
I think asking questions. As a scientist, you've just got to be curious, really, and ask questions about everything and anything. There is never a stupid question. All we do in science is basically ask a question, go out and collect some samples or some data so that we can answer that question. That's the fundamental thing we're doing as scientists. I also think you need to be brave. You need to be willing to get outside your comfort zone, to get uncomfortable, because it's there that you're going to do the really good science, and get noticed as women, certainly.
I also think that braveness comes from being willing to fail. And a lot of science is trying things that never work. But we only find out how something works by trying trial and error, doing lots of things. And sometimes you might think that you've done something wrong, whereas actually you've just asked a question and your answer didn't come back the way you thought it might. That's a really important part of the scientific process, is kind of asking questions you don't know the answer for. And so sometimes it feels like you're failing when actually you're just doing good science. So not being afraid of failure is a quite an important skill as well.
Brilliant. Thank you both very much. This is from Dinting. They're asking, what's the best part about being a scientist?
So I think, oh, you go, Ceri.
Thanks, Georgie. I was just going to say, for me, it's definitely the opportunity to take people like Georgie to places like Galapagos. Obviously, it was very exciting when I got to go there the first time as an early career scientist, but now I get to share those wonderful experiences with the next generation of scientists. I'm getting to go to incredible places and really do something positive to help those environments. That is a huge privilege, but then getting to share that with people like Georgie is just brilliant.
Yeah, I definitely say that the traveling and the getting to see new places, but also just learn new things. I mean, as a scientist, you're always learning something new. And that really is really thrilling, because you're never stagnant. You're never kind of staying still. You're always trying to learn more and know more about something, which can be really exciting.
Amazing. Thank you both. We have a question from Amaya. Hi, Amaya. Would like to be a marine biologist when she is older. What top tips would you give her?
I think take every opportunity to get a little bit of experience, whether it's volunteering for a local beach clean or helping one of your local wildlife trusts do some counting of things, because certainly marine biology is popular, and the jobs are quite often, lots and lots of people apply for them. Do a marine biology degree. There are so many wonderful marine biology degrees out there, not just at Exeter. Other universities in the UK do them as well. But then add to that degree with those opportunities to volunteer. There are lots of exciting projects happening around the UK at the moment. There's a thing called marine restoration. So people are planting seagrasses to try and restore those habitats, or restoring oysters, and they want volunteers all the time. Any way in which you can get involved in those projects will make you more competitive for the jobs when you're at that stage.
I'd also add to that, don't be afraid to approach people. If you have questions or you want experience but you're struggling to get it, then don't be scared. Approach these people, send them an email. They'll probably be really excited to hear from you. Even if they can't offer you any experience or an opportunity, they might point you in the direction of somewhere where you can get it. So yeah, don't be afraid to approach those people, even if maybe they're a bit scary. And also, like Ceri said, there's lots of citizen science programs and apps that are now being developed where you can get involved in marine science and science in general without even realizing. And that might be just if you're at the beach and you see a certain species of wildlife, and you then go on the app and you log it and you say you've seen it. So there's ways to get involved in science that you might not even have thought about.
Brilliant. Thank you. I think we've got time for just a few more questions. One question that's come through is, are there any famous female scientists that classes can research? I know we've mentioned two, Rachel Carson and Sylvia Earle. We've also mentioned Ada Lovelace. Jane Goodall would also be, who's just simply awesome. I know my daughter is in love with the book about her. But are there any other scientists, female scientists, you would recommend? Or you
have to say our professor and mentor Tamara Galloway, who was recently given an OBE by the Queen while the Queen was still with us, for her leading the research on plastics. And much of the government policies, the reason we're having single-use plastic bans being put in now is because of the work that Tamara pioneered. And you can find a bit of information about Tamara on Wikipedia, but she's not on Twitter, I'm afraid.
Brilliant, thank you very much. So there's been a lot of interest as well in what's it like to work up in the Arctic, Ceri? What's that like? It's not always this sunny, lovely, minus not too much weather. What's it like working in the Arctic?
Well, you can tell it's not too cold in that photo, Jamie, because we're smiling and our faces aren't frozen. Obviously, it can be incredibly cold, and the challenge is always to keep your equipment working when it's below -20. Everything starts to freeze, and because we are working obviously in the ocean, all of our kit is going in and out of the water all of the time, and so yeah, really challenging to keep our kits from not freezing. And quite often I was having to put probes, like special probes that we were putting into the ocean, into my jacket, shove them under my armpit to keep them warm in between sampling. But it's an incredibly beautiful place to work, and a place I absolutely love. So you put up with the cold and the finger pain because it's such a privilege to be there.
Amazing, thank you. Very sadly, we're coming towards the end of this live lesson. And I just want to give you the opportunity to share any final messages you have. We talked about boys and girls, but whoever you are, science can offer so much. Any final messages?
I think just learn about as many different skill sets as you can for being a scientist. Like I say, it's not about being a man in a white coat. You can be a digital scientist, you can be a field scientist, you can be a lab scientist, or you can be someone who just processes numbers. There are so many different skills involved. I think anybody can find their home within the scientific world if they want to look. So just go and see what the options are.
Yeah, and I think, as I said earlier, just stay curious and stay asking those questions and be passionate. Like Ceri said, find that part of science that you really like, you really enjoy, and you're really passionate about, because that passion will always shine through, whether you're in an interview for a job, or you're trying to get a university place, or you're just trying to get a bit of work experience. If people can tell that you're really passionate about that, that's going to help a lot.
Georgie, Ceri, and all the classes watching, thank you so much for being part of this Women on the Frontiers of Climate Science, celebrating the International Day of Women and Girls in Science. It's been a pleasure to have two awesome scientists with us. Thank you so much. Until the next time, but it's goodbye for now. Bye-bye.
Bye.
Bye.